Hello, this is Mr. Jones. Tomorrow when you come to class, that's Tuesday, we're going to be discussing the distance formula. So the distance formula, you get that from Pythagorean theorem. It is Pythagorean theorem, and you just have to do some substitution, and then you end up with the distance formula. So for today, I want to do a little review of Pythagorean theorem. But let me first just show you how the distance formula works, how that's related to Pythagorean theorem. Well, over here I want to find the distance of this line. So from one endpoint to the other, and actually I should have said segment, right? It's not a line, it's a line segment. So I want to find the distance from one endpoint to the other. Now the points aren't highlighted, but at the very end there are endpoints, even though we don't have dots to represent those. So how long or how far is it to go from the endpoint towards the right all the way to the endpoint on the left? Now you just can't count on your graph. I know this one has x is 4 is where it starts, and it ends at x is 8. So 8 minus 4 is 4, but that's not the distance because this is a diagonal. The diagonal is longer than it was just horizontal. So the way we find the distance for this is we're going to make this into a triangle. We're going to add lines that aren't part of the problem. We're going to add a line going left and right, just a horizontal line segment, and it's going to start at the left part of that segment, the diagonal segment, and it's going to end right underneath. It's still going to go all the way to x equals 8, right underneath the diagonal. All right, and then we're going to add another one that's going to go vertical. So it's going to go vertical down from the top right diagonal all the way down to where it's even with the bottom of the diagonal, which is also going to touch that red line segment that I added in. Now we have a right triangle. Now I could count this side, which I would call B, and the red side I'd call B, and the green side I'd call A, and then I could do my Pythagorean theorem. So I had a friend come from very far away, 2,300 years ago. He came into the present, traveled all the way across the ocean to come and teach us Pythagorean theorem. So listen up. All right, thank you.
Hello, this is Mr. Jones. Today we have Pythagoras with us. It's good to have you, Pythagoras.
Well, thank you for having me.
Pythagoras, I was wondering if you would mind reviewing with us Pythagorean theorem.
That'll be fine. Oh, well, okay. Back up and give me some room. So as you notice here, we have a triangle labeled alpha, beta, gamma.
Can you please use English, not Greek? Thank you.
Okay, so we're going to do this in English. So over here we have A, side A of the triangle, side B, and these are going to be perpendicular. Therefore we have a right angle, and therefore this triangle is a right triangle. The diagonal, the hypotenuse, is across from the right angle, and that is side C. Now sometimes you could switch A and B and it doesn't make a difference. Matter of fact, all the time, it never makes a difference. But C must always be the hypotenuse. So I noticed that there was no way of figuring out a third side. If I knew two sides of the triangle but didn't know a third side, there was no direct way to calculate that third side. But I did discover an indirect method. I noticed a relationship between the square of the sides. So side A, if I square that, I have a square. All the sides are equal to side A of the triangle. and then B, a square there. When I add these two squares, the area of these two squares, it will always equal the area of the hypotenuse. So I believe you're going to be doing more exploring with Pythagorean theorem in class, and you're going to learn more about how it connects to the distance formula. Good luck. Maybe I'll see you back sometime later on in the year. You have a great year. Bye.